All right. So for the first part, for this week, just rewatch the transformation section because what we're doing is doing more than one motion at a time. So we do a translation and then a reflection, or like a reflection and then a rotation. Okay, so look back at the transformation section for the first part of this. The second part is dilation. Dilation is multiplication. So if you're doing a dilation of 2, okay, let's say these are your dots right here, and then let's do something like that. Actually, let's erase this one, move a little up. Okay, so let's say these are your dots, right? Dilation 2 means that it is expanding from the origin. So whatever the distance is from the origin, it's going to be doubled. So how far is this dot from the origin? It's 2 to the left. So if we double that, we'll be going 4 to the left. So 1, 2, 3, 4, right there. Now we are doing this one. Now this one is 3 to the right, so 3 to the right, and then we're going 2 up. So we're going 2 up. Now remember, our dilation is 2, so we're doubling these motions. So it's not going to be 3 to the right, it's going to be 6 to the right. It's not going to be 2 up, it's going to be 4 up. So then you do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. Last one is just what? 3 up. So 3 up, but we're doubling it because the dilation is 2, means that we're going to be doing 6 up. So from here, 1, 2, 3, 4, 5, 6. And that, go back one. And this is a dilation of 2. Okay? And that's it. Okay, so that's how you complete a dilation when it's getting larger. Now we're going to do a dilation when it's getting smaller. So let's do one that's like 1/3. Okay, because dilation is always multiplying, the only way to make something smaller is to multiply by something smaller than 1, which is 1/3. Now 1/3 is the same thing as dividing by 3, just so you know. So when we multiply by 1/3, that's just going to be dividing by 3. So let's say I have one here, I have one here, and I have one here. Okay, so this one is 3 to the left. So 3 to the left, if I divide this by 3, I'm going to get 1. So now it's just going to be 1 to the left. So my new one is going to be right here, 1 to the left. Now let's change this one. This one's 3 to the right, so 3 to the right, and so 1, 2, 3, 1, 2, 3, 3 up. 3 to the right, 3 up. And now we have to make that 1/3 of it. So now it's not going to be 3 to the right, it's going to be 1. I'm going to divide that by 3. 3 up is going to become 1 up. So 1 to the right, 1 up. And then this one is going to be 6 to the right and 3 down. So if it's 6 to the right, and 3 down, okay, if I divide those by 3, I'm going to get 2 to the right and 1 down. Okay, so 2 to the right and 1 down, and that is a dilation where it shrinks it. Now dilation is a weird thing because it's much easier actually without the graph. So if I had 3 points like 2, 5, 1, 7, 3, 9, right? Let's say I have all 3 of these points. And I say, I want a dilation of 4. Well, all I would have to do is multiply everything by 4. So A prime would end up at 820. B prime would end up at 428. C prime would end up at 1236. And then you're done. Okay, so actually, off of the graph, it's actually much faster. Now, the last thing we're going to be talking about is the definition of congruent. Now, congruent is the geometry word for equal, meaning everything is exactly the same. So if I were to move a shape from here to here, the two shapes are congruent. Okay? Everything about them is exactly the same. Every angle is the same, every side is the same. And yeah, that's it. All right?